So to follow on from the other carbon structures session we looked at, there are some more allotropes of carbon that you need to know of. If you haven't listened to the other allotropes or allotropes of carbon or carbon structures session, then I recommend you doing that first. So, some other allotropes of carbon that you need to know of. The first one is graphene. Now, graphene conducts electricity because each carbon atom has a delocalized electron. Now, graphene is a bit different to graphite, which also has a single delocalized electron, because graphene is a single layer of graphite. So it also conducts electricity because of those carbon's delocalized electrons. It's very light, but very strong. So graphene is one atom thick, so just one layer. And this means that it's almost a two-dimensional structure, which means it's very, very light. However, because of the strong covalent bonds between the carbon atoms, it means that it's also very strong. And some of the uses of graphene are that they're used in electronics a lot and also in composite materials. Now, composite materials are just materials that have things added to make them more useful. And the reason graphene is good for those products is because graphene increases the material's strength without adding much weight. And also graphene can be used in solar panels, batteries, and much more. So remember that graphene is a single layer of graphite. And in terms of thinking about which are harder compounds, so graphene is harder than graphite. That's because it doesn't have layers. Diamond is harder than graphite, and diamond is harder than graphene. Fullerenes are molecules of carbon atoms that have hollow shapes, and their structure is mainly based on hexagonal or six-sided rings of carbon atoms. But they can also contain pentagonal, which are five-sided, and heptagonal, which are seven-sided rings. So there are these fullerenes called Buckminster fullerene, which is quite a difficult word, but all that means is that the fullerenes are spherical. And this was the first fullerene to be discovered. It has a chemical formula of C60, so it's just 60 carbon atoms, and it's technically a simple molecule because of its fixed size. Now, spherical fullerenes are quite useful, and they generally come in a wide range of sizes. But some of their most common uses are as catalysts for reactions. They can also be used as lubricants, and they can also be used for drug delivery in the body. Now, you can also get cylindrical fullerenes. Now, they're basically what we call carbon nanotubes. So if you think of a cylinder, and it's made of the fullerenes, so there's hexagons and pentagons and heptagons of carbon. Now, they're often called like molecular wires because they're so small in diameter and they're incredibly long, and they're the shape of a wire. Now, cylindrical fullerenes, because they have strong covalent bonds between carbon atoms, those nanotubes are exceptionally strong for their size. And some of the uses for cylindrical fullerenes are in electronics, in nanotechnology, and for strengthening materials. So, for example, a tennis racket frame. And the structure of fullerenes is usually based on hexagonal six-sided rings of carbon, but it can also contain pentagonal and heptagonal. So remember, pentagonal means five-sided, heptagonal means seven-sided rings. So let's recap some of those uses of fullerenes. They're useful as lubricants for the delivery of drugs and as catalysts. And the properties of graphene. They contain covalent bonds, which make them very strong. They conduct electricity and they're very light. So the structure of fullerenes is based primarily on rings of 6 carbon atoms. But don't forget, you can also have 5 carbon atom rings and 7 carbon atom rings. Carbon nanotubes are often called molecular wires as they have a tiny diameter and can be incredibly strong. And they can also be very long.